Okay, guys, so we are on problem E. So for problem E, we have a solution of aluminum sulfate that is mixed with a solution of calcium hydroxide. All right, so let's get it. We have aluminum sulfate. So you guys should realize that aluminum is going to be Al. Sulfate, if you take a look at your polyatomic ion sheet, is going to be SO4. And then it is being, got confused for a minute, it's getting mixed with a solution of calcium hydroxide. And then we need to figure out what type of reaction it is. I'm hoping that by now you guys will know that this is a double replacement reaction. The like charges are going to swap places. Aluminum is positive, calcium is positive. They are the ones that are going to switch. So on the other side, you should have Al. Oop, hold on, I'm getting ahead of myself here. We have Al, and that's going to be with hydroxide now. And then we are going to have calcium, which is going to be chilling with sulfate right now. Right? Let's write these formulas correctly. So we have aluminum. Aluminum is going to have a +3 charge. Okay? Remember, it is in group 13 along with boron, so they are all +3. If you were to take a look at the charge of sulfate on your polyatomic ion sheet, I'm hoping that you would see that it's -2. Calcium is a group 2 element, then it's going to be +2 as long as my pen is working properly. Hydroxide, polyatomic ion, is going to be -1. On the other side, we have aluminum that is going to be still +3. We didn't change anything. Hydroxide still -1. Calcium is still going to be +2. And sulfate is going to be -2. All right. Let me back up for a second and just write in that this is a double replacement reaction just so that we're all on the same page. And now let's go back and write the formula properly. So remember, we are going to cross the number, not the charges. So we're going to have Al2, and then I'm going to need 3 of those. Over here, we have calcium. We're fine because there's a 1 there. We're going to cross that 2, bring it down, polyatomic ion, put parentheses. Aluminum hydroxide, aluminum is fine because hydroxide is -1, but we have a +3 above the aluminum, so we need to cross it and bring down the 3. Over here, we have calcium that has +2, sulfate has a -2. We are all set with those. Okay, so now that I no longer need the charges, I am going to get rid of them. Hopefully not get rid of the equation that I wrote to, because that would be a shame. All right, so now we are going to balance our equation. So to balance our equation, we need to take a look at our problem, children. So remember, guys, this is another big rule that I said, when you see 3s and 2s, put 3s and 2s. So if you take a look, I have a 3 on my hydroxide. I have a 2 on that hydroxide. When I see a 3, I'm going to put a 2. When I see a 2, I'm going to put a 3. Okay? That's going to start us down this road of balancing. Okay, so hopefully you guys remembered that rule. All right, now let's get to balancing the rest. So my only problem child right now is calcium, right? So I have 3 calcium on here. I only have 1 over here. I'm going to need a 3 here. And I think that might solve all of our problems. I have 2 aluminum, 2 aluminum. I have 6 hydroxide, 6 hydroxide. I have 3 calcium, and I have 3 sulfates and 3 sulfates. That is your balanced equation for a reaction between aluminum sulfate and calcium hydroxide. Hopefully that was helpful.